Welcome. In this video, we're going to use the table and what we've learned about the rules for derivatives to find h prime of -2 and q prime of 0. So now the directions we're given are, suppose that f and g are differentiable functions, and we know the following table below. So this table gives us some inputs and some outputs for f, g, f prime, and g prime. Furthermore, define functions h and q as follows. H is equal to x squared times f of x, and q is equal to g of x plus x divided by f of x. So let's begin. Now, before we even think about trying to find h prime of a particular value or q prime of a particular x value, what we need to do is find a formula for h prime of x and for g prime of x. So let's begin with h prime of x. Well, this is a product of two functions, so we are going to use the product rule, that is x squared, we need its derivative, times f of x, plus x squared without a derivative times f prime of x. So h prime of x, all we really need to do here is use the power rule to find the derivative of x squared, and this is just 2x, now times f of x plus x squared times f prime of x. So there's h prime. Okay, so now that we've done that, let's go ahead and find h prime of -2. Well, h prime of -2, this tells me to replace every x here with a -2. So definitely we want f evaluated at -2, f prime evaluated at -2, but we also need to multiply -2 to 2 and take the square of -2. That is, multiply it to itself. So 2 times -2 times f of -2 plus -2 squared times f prime of -2. And then just to make it clear, every single x was replaced with a -2 above. So h prime of -2 is equal to -4 times f of -2 plus 4 times f prime of -2. Well, what is f evaluated at -2? Here is f, here, oh, that's not -2, excuse me, here's -2. It is 3. So on my next line, I have h prime of -2 equals -4 times 3 plus 4. And now let's quickly determine what is f prime evaluated at -2. That would be here. So that's 2. So 4 times 2. Okay, so we can finish now. H prime of -2 is equal to -12 plus 8. So it is just equal to -4. All right, as you can see, I went ahead and cleared my workspace here so we can find a derivative function for q and then evaluate this derivative function for q when x equals 0. So q, oh, that's a g, excuse me, q prime of x is equal to the derivative of our numerator, so g of x plus x, times the denominator, minus our numerator, no derivative, times the derivative of our denominator, and divided by the square of the denominator. And be very careful here, our numerator is glued together like a group, so we have to multiply the entire numerator by the derivative after this minus sign, which is why I have these extra brackets around it, and this is why I have the brackets here, and the derivative outside is telling me I need a derivative of each part. Okay, so q prime of x is equal to, well, the derivative here of g is g prime of x. The derivative of x is 1. So this is g prime of x plus 1 times f of x minus, and again I have g of x plus x minus this entire numerator of the original function times f prime of x, and then of course I'm dividing by f of x quantity squared. Now, I'm going to warn you to just keep it simple and don't start, getting all fancy with your algebra and distributing and combining like terms and trying to find some simplification. Really, this is just our means to an end of evaluating this derivative. So let's go straight into figuring out what q prime of 0 is equal to. Well, it is equal to g prime of 0 plus 1 times f of 0 minus g of 0 plus 0 times f prime of 0 divided by f of 0 quantity squared. And all I have done again is taken every single x here and replaced it with a 0. All right, so now let's actually figure out or use our table to finish Okay, so now we just need to use our table to evaluate g prime of 0, g of 0, f prime of 0, and f of 0. So I'll begin with g prime of 0. G prime of 0. That's equal to 3 here. And I'll write that down. G prime of 0 is equal to 3. Well, let's find next, let's say, g of 0. G of 0 is equal to negative 1. Now, what is f prime of 0? F prime of 0 is 6. And then f of 0 is equal to negative 2. Okay, I'm going to make a little space, so pardon me while I shift the screen. Okay, so I have shifted the screen so we can finish this problem. Q prime of 0 is equal to 3 plus 1 times negative 2 minus negative 1, and I'm not going to bother writing out plus 0 here. Anything plus 0 is just itself. So just minus a negative 1. And I think I will just switch to parentheses at this point. If that's confusing you, just know that you can use brackets to represent parentheses and vice versa in this manner. And I just decided to use brackets since we already had parentheses in the function notation. But since this is gone, I figured it was safe to switch back to parentheses. That tangent aside, we're going to multiply this negative 1 to the value of the derivative of f of 0, so that is 6. And then we're dividing this entire quantity times f of 0, and then we're squaring that, so negative 2 quantity squared. So what does this yield? 4 times negative 2 plus 6 divided by 4. That's negative 8 plus 6 over 4, or negative 2 over 4, which is negative 1/2. So Q prime of 0 is equal to negative 1/2. Hopefully this video is helping you improve your calculus skills.